So the third thing about that we know about the nuclear force is that it cannot it interact simultaneously with other nucleons. So by nucleons we mean protons and neutrons, with other nucleons for heavier atoms. So to understand number 3 further, we have here a graph of, in the y-axis we have the binding energy per nucleon. So you can think of it as the amount of electron volts you need to combine one proton and one neutron. And in the x-axis we have the mass number. So the mass number tells us how many nucleons are there inside the nucleus. So let's start with hydrogen. So hydrogen has a low binding energy per nucleon, in the sense that you only need a certain amount of EV for one proton and one neutron to bind. So as you go up the periodic table, for example, here in I think S is sulfur. So sulfur has a mass number of 34. So that means you have 34 nucleons inside the nucleus of a sulfur atom. So that means if you have more nucleons, so I'll write one nucleon as Pn here. Of course, one nucleon is equivalent to one proton or one neutron, but for the sake of simplicity, I'll write it as Pn. So here we have one nucleon, another nucleon, another nucleon, and we have 34 of those. So it has a higher binding energy per nucleon because this particular nucleon is binded to this nucleon, and the 34 other nucleons. So as you increase the nucleon count, or the mass number, in this case, a single nucleon experiences a higher binding energy because of the presence of the other nucleons. So as mass number increases, in this case, the binding energy felt by an individual nucleon also increases. But there comes a point wherein, as you increase the mass number of the nucleus, the binding energy suddenly drops, and there is a certain element wherein it's called the most stable nucleus, because it has the highest binding energy, and it has the highest binding energy per nucleon for all the other atoms. So let's first understand why does the binding energy drop as you go further higher up this mass number. So back to our third point, it can interact simultaneously with other nucleons for heavier atoms. So example here, uranium 235. So uranium, mass number of uranium here is 235. So let's scale up here. For example, we have one nucleon here and 235 other nucleons. So it's a big nucleus. So this individual nucleon can only interact simultaneously with its immediate vicinity. So it can only experience binding energy from this region. Same goes, for example, you have another nucleon here. It can only experience a binding energy in this region. So that's why as you increase the mass number further, the binding energy comes to a drop. You call this behavior saturation. So the binding energy gets so saturated that individual nucleons can only experience the binding energy in their immediate vicinity. So what does this have to do with iron? So iron is the most stable nucleus because due to its mass number count, every nucleon, for example, a nucleon here, feels every other binding energy inside the nucleus. So it's sort of like maximize the binding energy per nucleon, and that's why it has the highest amount of binding energy per nucleon.